As greenhouse gases are released into the atmosphere via human activity, and as the planet warms in response, climate scientists have observed ice in Greenland and Antarctica melting. This is of course problematic for animal species that live in the Arctic and Antarctic: polar bears, Adelaide penguins, and krill, among many others. But melting polar ice indirectly affects humans as well, most notably through sea level rise. A new study uses satellite data to estimate the amount of melting that has taken place in Greenland and Antarctica since 2003, and the amount of sea level rise that has occurred as a result. How does melting ice cause sea level rise? Ice that is floating in a glass of water melts, but will never change the water level in the glass. The reason is because floating objects displace an amount of water equal to their own weight. This effect is known as Archimedes' principle. When the ice cube melts, it becomes more dense and less voluminous, taking up only the space evacuated by the ice, without changing the water level. Similarly, an iceberg floating on top of the ocean will not change the sea level when it melts. You may have heard climate skeptics make this point in an effort to minimize the severity and potential consequences of global warming. But here's the catch. In Greenland and Antarctica, much of the melting ice is not floating. It is stored on land or grounded near the shore, and as a result, any melting that occurs will add water to the ocean and cause the rise in sea level. Measuring ice loss with ICESat and ICESat-2. To estimate the amount of ice mass that has been lost from Greenland and Antarctica, and therefore the amount of water added to the ocean, a team of scientists employed two special NASA satellites. The Cloud Ice and Land Elevation Satellite, known as ICESat, operated from 2003 to 2008, and its successor, ICESat-2, was launched in the fall of 2018. From their position in orbit, both satellites emit pulses of light, which bounce off the ice surface and return to the satellite. Based on the time it takes for the light to return, the elevation of the ice surface, and therefore the ice thickness, can be calculated. As ICESat-2 and ICESat orbited the Earth, elevation measurements were made across entire swaths of Greenland and Antarctica. By matching up the tens of millions of locations that had been measured by both ICESat and ICESat-2 over time, NASA scientists were able to determine where and how ice mass had changed between 2003 and today. Surprisingly, both northeastern Greenland and eastern Antarctica actually gained ice mass since the mid-2000s. This is likely because warmer temperatures are driving more evaporation, higher air moisture, and more inland snowfall. But overall, it was determined that ice loss near the coasts of both continents far outweighed the ice mass gained inland. Greenland and Antarctica lost an average of 200 and 118 billion gigatons, respectively, of ice per year since 2003. 1 gigaton of ice is enough to fill 400,000 Olympic-sized swimming pools. Implications of sea level rise. This amount of ice has ultimately led to a half-inch rise in global sea level in the last 16 years. While this might not pose an immediate risk to the majority of the human population, many low-lying island nations have average elevations of less than 6 feet and are on the verge of disappearing beneath the waves. Furthermore, the warming and melting trend is accelerating. The less ice that exists on the Earth's surface, the less sunlight and heat is reflected back into space, and the more that's absorbed by the planet. Light surfaces like ice have a higher albedo and reflect heat, while dark surfaces absorb more heat. Additionally, the disappearance of coastal ice destabilizes inland glaciers, allowing them to thin out and flow to the ocean more quickly. The ICESat missions have allowed scientists to make the most precise measurements to date of the speed and magnitude of polar ice loss. And though NASA estimates that ICESat-2 will only operate for another year or so, this type of instrumentation is going to be vital as the climate continues to warm and polar conditions evolve. This post was originally made on May 27, 2020 by Amanda Semler. It was titled, "A Song of Ice and Sea Level Rise," and featured a paper by Smith et al. 2020 titled, Pervasive ice sheet mass loss reflects competing ocean and atmospheric processes. This has been Oceanbites Out Loud. Check out oceanbites.org for this post and other neat posts. Thanks for listening.